7 and problem 8 from various equations 2. All right, so the first thing I'm going to do is I'm going to move these two quantities that are not stuck with this to the right-hand side using inverse operation. So the negative 2x and the positive 6 move over, and now I have 2 times the quantity 3x plus 4 equals, let's combine like terms, to subtract 6 is negative 4. Now we have a value out front of 2. Opposite of multiplying by 2 is dividing by 2, and that 2 has to be shared with both items on the right-hand side. So I'm going to write it over 2 over 2x minus 4 over 2. And I can reduce both of those, and you could do that in your head, 1x minus 2. Goes back to now what we've done in problems 1 through 6. So in order to remove the square root, I'm going to square both sides. I get 3x plus 4 is equal to 1x minus 2 times 1x minus 2. Okay, now I'm going to multiply on the right-hand side. 1 times 1 is 1x squared. Negative 2 times negative 2 is positive 4. The inside is negative 2x. The outside is negative 2x. Negative 2x and negative 2x is negative 4x when you combine. Let's move everything to the side that has the x squared. So inverse operation says I do the opposite sign. So I have 0 equals 1x squared minus 7x, and the 4's cancel. Now to these two terms, I can factor out an x. I'm left with x minus 7. Here's 1x squared minus 7x. I'm going to take each one of those quantity, x and x minus 7, and I'm going to set it equal to 0 and solve. Well, the first is already solved. And then when I add 7 to the opposite side, I get 7. That doesn't mean automatically that these are the correct answers. We got to go up to the very beginning. We're going to start by plugging in 0. Negative 2 times 0 plus 6 plus 2 times the quantity of the square root, 3 times 0 plus 4. Now this better equal the quantity 2. It does not. I want to check to make sure it looks like I have plugged in everything correctly. So I do not believe that 0 is a solution. I believe it's an extraneous solution, which means we did the math right, but when you plug it in, it doesn't work. Now let's try, what was my other one? It is 7. Let's make sure I plugged this in correctly. 7, it should equal 2. It does. So we have one correct answer of 7. Let's look at number 8. Number 8. Okay, in number 8, I'm going to do the same thing. I'm going to add 3x to the opposite side and 8 to the opposite side. So I already had a 7. I'm going to add 8 over, and I'm going to add a 3x over. And then I'm going to combine like terms to get 3 times this quantity equals 15 plus 3x. Doesn't matter if you put the 3x first or the positive 15. Let's divide by 3, and I have 5x plus 19, the square root of. Now this has to be shared with both. So 15 over 3 and 3 over 3. Square root equals 5 plus 1x. And now to remove the square root, I'm going to square both sides. 5x plus 19, I need to write this down twice. Multiplying the fronts, multiplying the backs. Now the inside, 5x plus 5x is 10x. Let's move everything to the side that has the x squared. So inverse operation, in this case I am subtracting 19 and I'm subtracting 5x. 0 equals, of these 5 terms I have 1x squared, standard form. 10 minus 5 is 5. 25 minus 19 is 6. Is this factorable? Let's check. 1 times 6 is 6. Are there two numbers that multiply to give you positive 6 and combine to give you 5? Yes, 2 and 3. X plus 2 and x plus 3 equals 0. Set each of these quantities equal to 0 and solve. And we come up with the answers of negative 2 and an answer of negative 3. Now again, this doesn't mean those are automatically in the answers. We have to come up to the very front and we got to check to make sure, is this correct? Okay, so I'm going to start with negative 2. Negative 3 times negative 2 plus 3 times the quantity, 5 times negative 2 plus 19. Moving back of that, subtract, not negative, subtract 8. We want this to equal a value of 7. It does. Okay, perfect. Negative 2 works. Now I'm going to try negative 3. Negative 3 times negative 3 plus 3 times the square root of 5 times negative 3 plus 19. Plus 19. Moving back, subtract 8. We also want this to equal 7, and it does. That means both negative 2 and negative 3 are solutions to number 8.